Hello and welcome back to another video. In this video, we are going to discuss all about kinematics, which is one of a very important concept in physics AS level. We'll not just discuss the theory, but we'll also solve some important questions that's going to help you understand all about kinematics. Let's begin. Alright, let's begin. So kinematics is basically a branch of physics or mechanics that is concerned with the motion of an object without referencing to the forces acting on it. Okay, so let's start with some revision, but you do need to know this for AS physics. So what is the length between 2 points measured along a straight line joining 2 points? Alright, so they're saying if there are 2 points like this and let's say 3 points, and these points are connected by a straight line. This is 20 meters, this is 15 meters. So what is this entire length? This bit is just the distance. This is the distance traveled by the object. Now, if they're saying what is the distance of an object from a fixed reference point, that means the distance traveled by an object from the start. Here is the start and this is the end. So that would be something like this. What is that called? The shortest distance. Let's say it might be 17 meters. Just for reference, this is not the actual value. For example, this is known as the displacement. This is the shortest distance traveled. Now, what is distance traveled per unit time? Distance over time, this is obviously speed. What is change in displacement per unit time? That is velocity. Rate of change of velocity, that is called as the acceleration. Now, a scalar quantity has only magnitude, okay? While vector quantity has magnitude as well as direction. For example, if you talk about speed, let's say it's 20 kilometer per hour, that's just the speed. But if it says that it's 20 kilometer per hour in northwest, that is the direction. So that would be a vector quantity. So if you look at these quantities, can you identify which one is scalar and which one is vector? So distance is obviously a scalar quantity. It only has magnitude. Displacement is a vector quantity. What about speed? Speed is distance over time. Since both distance is scalar, time is scalar, so that means speed is also a scalar quantity. What about velocity? Velocity is displacement over time. Displacement is vector, making velocity vector as well. Finally, you have acceleration. This acceleration is also a vector quantity. If the acceleration is in the opposite direction, that is going to decrease its velocity. For example, if you say it's minus 2 meter per second square, it means every second the speed is reducing by 2 meter per second. If you say it's positive, this is also known as deceleration, okay? Negative acceleration is known as deceleration. If you say it's positive 2 meter per second square, that is positive acceleration. It means every second the speed is increasing by 2 meter per second. If there is an acceleration which is at 90 degrees to the motion of the object, the direction will change, but the magnitude of the object will remain same. It's not going to change. Now, let's look at some formulas. So, for example, if you say V equals to delta S divided by T, what does that mean? So, V is basically velocity. And we said velocity is rate of change of displacement. How does displacement changes over time? So whenever we say rate of change of something, it means it is divided by time. So t is time. And what about this triangle? This triangle means delta, and this means change in something, okay? So this is delta S. S means displacement. Now, if you look at another formula, for example, for acceleration equals to delta V divided by T. So you can identify that A is acceleration, T is obviously time, and delta V is change in velocity. You may know the SI units already. SI unit for velocity is going to be meter per second. SI unit for acceleration is going to be meter per second square. V equals to delta S divided by time. So what is the unit for displacement? It's meter. What is the unit for time? It's second. Therefore, velocity is meter per second. So acceleration is velocity over time. What is the unit for velocity? It's meter per second divided by time, divided by second. So we can also write this as meter per second times second, and this is going to give you meter per second square. And you can see these are same. Alright, now let's look at some practice questions. Feel free to pause the video and solve it on your own first. Now let's do it together if you're done. So a runner travels around one circuit of circular path of circumference 2.4 meter in 4.8 seconds. So first question is calculate the average speed. Remember the formula for speed? Speed equals to a change in distance over time, delta d over time. So distance traveled is 2.4 meter divided by 4.8 seconds. If you divide it, you will get 0.5 meter per second. Now in the book it says it's a good idea to write your units along with it, so you can see that your final answer is the same, it's correct. And in some questions you might be asked to identify the unit of an unknown quantity. So this will help you to know the units of the quantity that you're trying to find. The second step is find the average velocity. Remember the formula for average velocity? That is going to be change in displacement over change in time. Now displacement is the distance from the starting point to the final point. Or if you look at the definition, it says distance of an object from a fixed reference point, that is the starting point. So you can see it's 0 because the starting point and ending point is same. The distance between 2 points are 0. So this is going to be 0 meters over 4.8 seconds. So that is going to be 0 meter per second. Please pause for a moment and try to solve this first. If you're done, let's begin. A car travels 840 meters along a straight line at constant speed of 35 meter per second. So this is our distance and this is our speed of 35 meter per second. And then driver then applies the brakes. They're saying the car decelerates to rest. So this is an important quantity at a constant rate in further 7 seconds, so it takes more time. Now they're saying find the time taken for which car travels at constant velocity. Now initially the car was traveling at constant velocity before the driver chose to apply brakes, right? Time is going to be change in displacement over velocity. So that is 840 divided by speed, which is or velocity, which is 35. If you find this value, you will get 24 seconds. If you notice, our answer should be in two significant figures because in the question they are using two SF, 2 for 84, 35, and 7.0. Okay, so make sure your answer is also in two significant figure. Part B, acceleration of the car when brakes are applied. It says it was at rest, came to a stop. So this is going to be 0 meter per second minus initial velocity, which is 35, because at 35 meter per second the driver applied brakes, right? So that is the initial velocity, minus 35 meter per second divided by time, which is 7 seconds, negative 5 meter per second square. Now the minus sign indicates that this is deceleration. Okay, every second the speed is reducing by 5 meter per second. So let's look at these motion graphs. First, we have a displacement time graph where you have time on the x-axis and displacement on the y-axis. Now you can see this is a straight line starting from the origin. So you can see that displacement increases uniformly with time because it's a straight line. Now if you calculate the gradient, you can draw a triangle like this. You can take any 2 points. For example, we're considering this point and this point. This is your second point. So you can see this is change in displacement and this is change in time. This is nothing but what you have studied in IGCSE. There is no new concept here. So velocity is delta S over delta T. This is the formula, right? That is the gradient. So that just means that when you find the gradient of a displacement time graph, what you will get is velocity. Now when you're trying to measure the gradient of a straight line graph, make sure that you use a big triangle. How do you do that? Make sure your points are far apart. It should cover at least more than half of the line, of the entire line, okay? So make sure your points are very far apart from each other. This reduces the percentage error in your calculation. Now on the other side, here it means that you can see that the gradient constantly changes, okay? So at this point, this is the gradient, okay? At this point, this is the gradient. You just have to draw a tangent at that particular point. So for example, if you want to find your speed or your velocity at this particular point, you will take your ruler and you will draw a line that extends something like this, okay? And then you will find the gradient of this tangent, this line that you just drew. This is called the tangent, and this will help you find the instantaneous velocity. You can see that this is a curve, right? So when there's a curve, it means the gradient or the slope constantly changes. That means the velocity keeps changing. So when there is a change in velocity, we call this acceleration, okay? Now I want you to be able to identify whether this graph is accelerating or decelerating, okay? How do you do that? Now if you look at, for example, something like this, can you identify at which point is the graph accelerating and at which point it's decelerating? So acceleration is occurring when the graph is becoming more steeper. So you can see at this point the graph is becoming steeper, right? So this is acceleration. Now on the other hand, if you see at this point the graph is becoming less steeper, right? So this is deceleration. And you can identify the regions of acceleration, deceleration from a displacement time graph. What is this? Can you identify the object? What is going on in the object? You can see as time is increasing, the displacement remains same. So that means the object remains fixated at that position. That means the object is stationary, okay? It's not moving. Its speed is 0. Because if you find the gradient is 0 because there is no slope. Slope is only when there is an angle, okay? Not a horizontal line. What if it's a velocity time graph? If you have a horizontal line at a velocity time graph, it means that the object is moving at constant velocity, okay? If you find the acceleration is going to be 0 meter per second square, okay? Because the speed is not increasing or decreasing. If you look at this velocity times graph, you can see that this is a straight line. A straight line represents uniform acceleration. That means the acceleration at this point and this point is same because the gradient is same. And how do you find the acceleration from a velocity time graph? You have to find the gradient, just how you did it over here. So acceleration is going to be change in v divided by change in time. This is our gradient. You're solving your question in the past paper, it is a good idea to show this triangle. So show them that you actually found this from your graph, okay? This is delta v, delta t. Can you find the displacement from this graph? You can, if you find the area under the graph. So if you have a velocity time graph and if you need to find the displacement, all you have to do is find the area under the graph, okay? So draw this line here, and you can see that this is a triangle. So and the formula for area under the graph for a triangle is half BH. So this is going to be half multiplied by time multiplied by change in velocity, right? Now you can say this is v and this is u. Why? Because v represents the final velocity. This is v, the final velocity, and this is u. This is the initial velocity, okay? So you can write this as v minus u, and make sure to write brackets here because this is subtraction. So v minus u represents final velocity minus initial velocity. This is simply finding the area under the graph, and you have maybe they can ask you to find the area between any 2 points. Just identify the shape and find the displacement. A motorcyclist starts from rest and accelerates at 4.4 meter per second. Okay, so its initial speed is 0 and it's accelerating at 4.4 meter per second square for 7.5 seconds. So So you have time, acceleration, and initial speed, velocity. She then continues at a constant velocity for 20 seconds before applying the brakes and coming to rest in further 3 seconds. Calculate the maximum velocity. So acceleration equals final velocity minus initial velocity over time. And then AT plus U equals to V. So this is going to be 4.4 multiplied by 7.5 plus 0. This is the maximum speed. Okay, let's now draw a velocity time graph. Okay, so on the x-axis you need your time in seconds, and on the y-axis you need your velocity in meter per second. Now, the motorcyclist is starting from rest and accelerates at 4.4 meter per second square for 7.5 seconds. Okay, so we know we're starting here. We're starting from rest and moving until 7.5. But what is the speed? We just calculated that the maximum speed is 33 meter per second. So this is how it will be. Because it's accelerating, I'm drawing this slope. So this is on the y-axis is 33, and on the x-axis is 7.5. So the first part is done. She then continues at a constant velocity for 20 seconds. Okay, so for almost here, this is constant velocity, so it should be a horizontal line. What about the time? You will add 20 seconds. So this was 7.5. This was 7.5. 7.5 plus 20 is 27.5, which would be approximately here. And then she applies brakes and comes to rest in further 3 seconds. So 27.5 plus 3 is going to be almost 30.5, and then she's decelerating and coming to a break like this. So this is your velocity times graph. Alright, for the next step, you need to study something called as the equations of motion. Okay, so before moving on to these 4 equations of motion that you need to memorize, I want you to recall some equations that you have studied before. You know that speed equals to distance divided by time, and or velocity equals to displacement over time. So these equations are used to find speed or velocity when the acceleration is 0. But what about when there is uniform acceleration? What is it that you can do? You have to basically memorize these 4 equations. The first 2 equations are used to find the velocity, and the second 2 equations are used to find displacement. So v equals to u plus at, and then v square equals to u square plus 2as. Now v is the final velocity, u is the initial velocity, a is acceleration, t is time, and s is the displacement. And then there's another one, s equals to ut plus half at square, s equals to u plus v divided by 2 multiplied by time. Now in a moment we will see how are these equations derived. We will derive them from a velocity time graph. It's fairly simple, but before that, another important concept that is going to make solving very easy for you when you're trying to solve your past papers. Okay, so let's see when you have a falling object. Okay, you're standing on a height and you drop a ball or something down, and you're asked to find velocity or displacement. What do you do? In that case, is always remember acceleration becomes gravitational field strength, which equals to 9.8 meter per second square. So you will replace all of your a's with g. And then another thing is that initial velocity becomes 0 because it's initially at rest, and then you throw it down. Okay, v equals to gt. Okay, because u becomes 0 and a becomes g, which is 9.8 meter per second. For the second one, it's going to be v squared equals to 2gs. The third one would be s equals to half gt squared, and s equals to v by 2 multiplied by t. So you don't have to memorize these equations, you just have to memorize these important 4 ones, but you can see that you can simplify your equations to solve some questions. Now what about rising objects? Remember, for rising objects, the initial velocity may not be 0, so you will have a value. But what about a? A will become negative g, which equals to negative 9.8 meter per second square. V equals to u minus gt. Okay, v square equals to u square minus 2gs. S equals to ut minus half gt square, and s equals to u plus v divided by 2 multiplied by time. Memorize these big four equations and you will be able to solve most of the kinematics questions. Alright, for the next step, you need to study something called as the equations of motion. Okay, so before moving on to these four equations of motion that you need to memorize, I want you to recall some equations that you have studied before. You know that speed equals to distance divided by time, and or velocity equals to displacement over time. So these equations are used to find speed or velocity when the acceleration is 0. But what about when there is uniform acceleration? What is it that you can do? You have to basically memorize these four equations. The first two equations are used to find the velocity, and the second two equations are used to find displacement. So v equals to u plus at, and then v square equals to u square plus 2as. Now a v is the final velocity, u is the initial velocity, a is acceleration, t is time, and s is the displacement. And then there's another one, s equals to ut plus half at square, s equals to u plus v divided by 2 multiplied by time. Now in a moment we will see how are these equations derived. We will derive them from a velocity time graph. It's fairly simple, but before that, another important concept that is going to make solving very easy for you when you're trying to solve your past papers. Okay, so let's see, when you have a falling object. Okay, you're standing on a height and you drop a ball or something down, and you're asked to find velocity or displacement. What do you do in that case? Is always remember acceleration becomes gravitational field strength, which equals to 9.8 meter per second square. So you will replace all of your a's with g. And then another thing is that initial velocity becomes 0 because it's initially at rest, and then you throw it down. Okay, v equals to gt. Okay, because u becomes 0 and a becomes g, which is 9.8 meter per second. For the second one, it's going to be v square equals to 2gs. The third one would be s equals to half gt square, and s equals to v by 2 multiplied by t. So you don't have to memorize these equations, you just have to memorize these important four ones, but you can see that you can simplify your equations to solve some questions. Now what about rising objects? Remember, for rising objects, the initial velocity may not be 0, so you will have a value. But what about a? A will become negative g, which equals to negative 9.8 meter per second square. V equals to u minus gt. Okay, v square equals to u square minus 2gs. S equals to ut minus half gt square, and s equals to u plus v divided by 2 multiplied by time. Memorize these big four equations and you will be able to solve most of the kinematics questions. Alright, now let's derive those big four equations of motions that we just studied from this graph. As you can see, this is a velocity times graph. There is uniform acceleration starting from u. This is the initial speed. After some time, it reaches v, which is the final speed. Now, if you want to write the acceleration from this graph, remember acceleration equals to delta v divided by delta t. This equals to v minus u divided by t. So if you have to make v as a subject, we can write this as at equals to v minus u. At plus u equals to v. If you just rearrange it, v equals to u plus at, and this is your equation number 1. That's how the first equation is derived. Okay, for equation number 2, remember s is the displacement of an object. If you remember, velocity equals to displacement over time. So displacement equals to velocity multiplied by time. But what if you need to find the average velocity? So s equals to average velocity times time. The average velocity of u and v, you just have to add them, u plus v divided by 2 multiplied by time. And this is the formula when you need to find an average of two quantities. Add them together, divide by 2. So this gives you your equation number 2. Now there's another way to find displacement. Okay, if you look at this, this is basically a velocity times graph. And if you remember, we just studied that if you find the area under the graph of a velocity times graph, what do you get? You get displacement, right? So let's try to find the displacement of this graph. So you have a rectangle and you have a triangle. So if we just add these two areas together, you will get another equation. So area of triangle equals to half BH. What is the base? This base is the time, so multiply this by time multiplied by this height. Okay, so this is going to be V minus U, because you don't need this area, it's only V minus U. So this is going to be multiplied by V minus U plus the area of rectangle, which is length multiplied by breadth, or length multiplied by height. So this one is simply time multiplied by this height. This is U times U. Let's simplify this a bit. Before simplifying it this further, we need to use this equation to get to our required final equation. So remember, acceleration equals to final minus initial velocity divided by time. And if you see, we have V minus U. Okay, so AT equals to V minus U. We can write this as half multiplied by time multiplied by AT plus TU. You can get S equals to UT. I'm writing this one first, plus half AT square, right? If you see, this is the same equation as the equation that we have earlier, and this is how you derive it. You need to know these derivations because you can be asked to derive the fourth equation. We'll use the first equation and second equation to find our last equation. Okay, so here we'll make time as a subject. T equals to B minus U over A, and then substitute this in equation number 2. This is the second one. So S equals to U plus V divided by 2 multiplied by time. Instead of writing time, we'll write this V minus U divided by A. U plus V minus U divided by 2A. So this is going to be S equals to V square minus U square divided by 2A. Now if you're wondering how did we get this, this is basically a rule in mathematics. V square minus U square will give you U plus V, V minus U. Basically, if you have X square minus Y square, this is the same as X plus Y, X minus Y. Okay, if you simplify this, you will get this. So since we have U plus V, U minus V, we can write this as V square minus U square. So now I will move this U on the other side. 2AS plus U square equals to V square. So V square equals to U square plus 2AS. This is equation number 4, and we have derived it as well. I know this one was a bit complicated. Just remember, a first step is that we don't need the time, right? So we'll make T as a subject, and then we'll substitute this in equation number 2 and simplify it until we get the required equation. Alright, here now I have some practice problems. Try to read them and then pause for a moment before solving them. Okay, just a pro tip for you: before solving the equation, it's a good idea to write down all the equations that you do have, and then write down the quantities that are given in the question. Using these quantities, you can match the perfect equation to solve this question. Okay, if you're done, you can unpause the video and start. So here it says an athlete runs from rest and accelerates uniformly for 3 seconds at a rate of 4.2 meter per second square. Calculate final speed. Oh, okay. If you're not sure which quantity is this, just look at the unit. It says 4.2 meter per second square, so this is acceleration. So if you look at these quantities, the first equation is the perfect equation. V equals to u plus at. Initial speed is 0 plus 4.2 multiplied by time, which is 3. This is 12.6 meter per second. Alright, so the next question is that a car on test run enters a measured kilometer at a velocity of 28 meter per second. It leaves the measured kilometer at a velocity of 40 meter per second. Calculate. Okay, so this question says that there is a measured kilometer. That means there is 1 kilometer where the car enters at an initial speed or velocity of 28 meter per second and it leaves with a final velocity of 40 meter per second. Calculate the time taken between car entering and leaving the measured kilometer. Okay, so we have the distance and we have velocity, and we need to find the time. If you can see, we can use the last equation. So this is going to be 2s equals to u plus v multiplied by time. I added a bracket here. Why? Because there is a plus, right? These are being added and this is multiplication. And since there's a multiplication here, I need to move all of this down in division. So 2s divided by u plus v equals to t. So time equals to 2 multiplied by displacement, which is 1 kilometer. But wait, it's kilometer. So remember to convert this into meters. So 2000. 2 multiplied by 1000 divided by 28 plus 40. 29.4117. Remember, if you look at the question, these are given in two significant figures, so let's write our answer in two significant figures as well. This is going to be 30 seconds. The average acceleration, we can simply use a equals to v minus u divided by time. This is from the first equation because v equals u plus at. Okay, we made a as a subject. Final velocity is 40. The initial velocity is 28. Divide this by time, which is 30, and the answer is 0.4 meter per second square. Now we have to analyze motion in a uniform gravitational field. So what is happening to displacement or velocity under the forces of gravity? To do that, let's solve this problem, and it will help you to have an idea of what's going on. So it says that a boy throws a stone vertically up in the air with a velocity of 6 meter per second. So the initial velocity is 6 meter per second. This is the initial velocity. The stone reaches a maximum height and then it falls into the sea. Okay, like this, which is 12 meters below the point of release from his hand. Calculate the velocity at which stone hits the water surface. So what is the final velocity at which it's hitting the surface? Now if you notice, we have two directions, right? We have an upward direction and we have a downward direction. Since in the upward direction they said it's positive, our downward direction is considered negative for this example. As this displacement, what you will write is negative 12 meters, because for this question we considered downward to be negative and upwards to be positive. So s is negative 12 meters. Acceleration will be negative 9.81 meter per second square because it is accelerating downwards, right? V square equals to u square plus 2as. Let's make v as the subject. V equals to square root of u square, 6 square plus 2 multiplied by negative 9.81 multiplied by displacement is negative 12 multiplied by negative 12. The answer is going to be plus minus. Why plus minus? Because we have a square root. 16.47. These quantities were given in two significant figures, so the answer is 16 meter per second. Now what is acceleration of free fall? Okay, so on the surface of Earth, all the objects will fall with the same value of acceleration when there is no air resistance. Okay, when there's no force that is resisting the downward acceleration, all objects will fall with the same value, which is 9.81 meter per second square. This value is known as the acceleration of free fall. Every planet has its own particular acceleration. Okay, so on Moon it's going to be different, on Mars it's going to be different. Now there is an experimental setup which can be used to determine the acceleration of free fall. Okay, so in this experiment, what happens is that you have a stroboscopic light and a digital camera. On the other hand, you have a ball which is held at a distance, and then you have your meter rule. So this camera is kept open, the shutter is open, and you have a stroboscopic light which flashes at a fixed frequency. What is the need of these setup? Basically is that when you throw the ball just goes down, right? And then after that you get a photograph. This is the photograph that you get that shows the ball falling at a certain distance. For example, here, something like this. You will be able to see that this ball is accelerating, and you obviously have your meter rule beside it that is needed for you to determine the distance. Now using this information we can fill this table. Okay, so each image of this ball represents distance the ball has traveled every 0.05 seconds. Okay, what is the distance? The distance is the distance traveled between two positions, so you just have to subtract them. This is going to be 0.01 minus 0. This is 0.01, and then you have to subtract 0.05 from 0.01 to calculate the distance. This is going to be 0.04. Okay, so notice that the difference between position and distance. Position is where the ball is compared when you look at the meter rule, and distance is the distance traveled in this time period. Okay, using these values we can calculate the speed. Remember, speed is distance over time, so it's going to be this distance. Okay, not the position, make sure of that. Speed equals to distance over time. But what is the time? You can't for example, if you're finding the speed here, you have to subtract t2 from the previous t1, so it's going to be 0.05 minus 0 in order to find the time here. Or the last row, you have to subtract 0.15 minus 0.1. And if you notice, the difference between two consecutive values is 0.05. So you just have to divide this by 0.05 seconds. Moving on. Alright, now let's look at projectiles or motion in 2 dimensions. Okay, so in this diagram, let's say a missile is fired. It has it's a curve, right? And it's moving in 2 dimensions. We have a horizontal velocity and a vertical velocity. Vertical because this is going upwards, and then it is going downwards. So it has an upward and downward velocity. And it also has a horizontal component of velocity. We use the word component, that's important, going towards right. So it's going up and right, and then it's going down and right. Okay, that is 2 dimensions. So how do we solve equations, use equations of motion when you have 2 dimensions? How do we do that? We basically separate it into components. Let's say you have a velocity of an object. This object is moving in this direction. Maybe it's north-south or northeast, whatever. So it is moving right and upwards, right? We'll break down this velocity into x and y components. So we'll call this as v. This is velocity initially, and then on the x-axis we have a horizontal component, and on the y-axis we have a vertical component. So this is known as vx, and this is known as vy. To find out the values for vx and vy, we need to know the angle theta. Okay, this is known as angle theta. So what is vx and what is vy? To find that out, I'll tell you a simple rule. We have to multiply this with either it's either going to be v cos theta or v sin theta. How do you know whether to use sine or cos or cosine, sine or cos? You have to look at where angle is. So here you know the angle theta between v and vx. So that means you will use cosine. This is going to be v cosine theta. So let's say if v is 20, this is going to be 20 cosine whatever the angle is, let's say 5. And this value will give you the component, the horizontal component velocity. What about vy? This is just going to be v sine theta. Remember, it's a saying that stay away from sins. Okay, So since theta is away from you, you have to use sine. Okay. Now, one more important thing is when you're doing a projectiles or motion in two dimensions. So now you have horizontal and vertical motions, vertical motions, right? Remember, in horizontal motion, we have no acceleration. Acceleration is always zero. So you will use your regular equation, which is speed is distance over time, or velocity is displacement over time, whatever, without the equations, without the equation of motion, because acceleration is zero. But what about vertical? You do have the acceleration, which is 9.81 meter per second square. So you have to use the equations of motion. So this is very important. And one more tip I can add here is that, for example, if you have v equals to, you use this equation, u plus at. You can actually find the time taken, for example, the time taken to reach at this point, and then you can use this value for time and plug it over there, okay, to find the unknown value for v, for example. So this is used a lot. By the way, the path that an object follows, this is known as a parabola, okay? Now let's have a look at a worked example. Alright, now let's do a practice example of motion in two dimensions or projectiles. Now if you are able to do this on your own first, I highly encourage you to do it. Remember to find the components. You have to find the components using this method. And then to find the time taken or the speed in the vertical direction or any of that, you have to use the equations of motion. To find any horizontal speed or distance, you have to use a regular speed is distance over time equation. Okay, so the question says a golf ball is hit so that it leaves the club at a velocity of 45 meters per second at an angle of 40 to the horizontal. Okay, before moving on, let's draw what's going on. Okay, so you have this ball. This ball is shot at 45 degree to the horizontal, right? This is the earth. And then you're supposed to calculate the horizontal component of initial velocity. Okay, so horizontal component is this direction. Remember, if you have the angle theta between what you want and your velocity, or any vector, it could even be force. You will see that in future or upcoming chapters. It's going to be any vector quantity. Ux equals to u cosine theta. U is 45, cosine 40, and this is going to be 34.5 meter per second. The vertical component, which is the velocity in the vertical direction. So this is going to be sine, because you don't know the angle, so it's away from you. U sine theta is equal to 45 sine 40. This is going to be 28.9 meter per second. I mean, you don't know the angle between the vertical and the velocity. You know the angle that's away from you. That's why you use the sine. Now the time taken for the ball to reach its maximum height. Okay, if you see, this ball follows a projectile, right? It moves something like this. This is the initial point. Now to reach its maximum height, this is the point. So the ball is hit at this point, and then it rises and until it reaches a maximum height. After that and beyond that, it's falling down, right? So it has a point of maximum height. Now the key thing to notice is that this is the maximum height, right? At this point, it stops for a moment before falling down. Okay, so we will say v then becomes 0 meter per second. That's an important concept. And what about initial velocity? So you have two components of initial velocity. You're finding the maximum height. So this is in the vertical direction. You need to use the vertical component of initial velocity. So you have to use u, which is 28.9 meter per second. Now, is there acceleration or no? Of course there is, because there is force of gravity acting as the ball is going upwards, right? So we have to use equations of motion. We cannot use speed as distance over time or velocity as displacement over time. So we have to consider acceleration. We can simply use the first equation, v equals to u plus at. We have to make t as the subject, so v minus u divided by a equals to t. So t is going to be final velocity is 0 minus 28.9. What about the value of acceleration? This is going to be g, but since this ball is rising, it's going to have negative a. It's going to be negative 9.81. You will get 2.94. Now we're going to talk about the horizontal distance traveled when the ball reached the maximum height. So first you calculated this height, right? The maximum height. Now you need to find the horizontal distance traveled. Remember, in horizontal distance, there is no acceleration, okay? So you can simply use the regular equation. So s equals to v multiplied by t. You can even write it's even better to write u, because v is final velocity for us, right? We're considering u. It's not going to, I don't think it's going to affect your mark. I believe you'll get it, but just for more clarity, we are using u to show that it's the initial velocity. So displacement is going to be u. Now we have to use the horizontal component because this is the distance traveled in the horizontal direction. So this is going to be 34.5 multiplied by time, which is 2.94. This is going to be 101 meters. Now we have to write that, we can write this in two significant figures. Why? Because if you look at the question, this is given in two significant figures. These are basically interim values or intermediate values. We are using these to come to the final answer, so we didn't round these off. That's what they did in the book. Now moving on. So this is an important concept to know, this question. So it says a gun is shot at 90 degrees to the horizontal with an initial speed of 40 meters per second. Calculate the horizontal and vertical component of u. This is your x and y axis. And the ball is shot at 90 degrees to the horizontal. So this is your angle, and this is the speed, right? Without any calculation, you can see that in the horizontal component, it's going to be 0 because it's simply traveling along the y-axis. So we can say vy equals to 40 meter per second, and vx is going to be 0 meter per second, or u rather, okay? It's better to write u because it's initial speed. Now you can also show this with calculation. To find the horizontal component of initial velocity, we have to use cosine 90. Why? Because we do know the angle between the x-axis and the velocity given to us. Okay, it's known to us. That's why we use cosine 90. That is why for uy we have to use sine 90. That's all about kinematics. If you have any questions, make sure to ask them in the comment section below, and please recommend what future videos should I make